When people think of pollution, certain images come to mind. Smokestacks, oil, litter, car exhausts.
But there's another culprit helping pollution flow into our rivers and oceans. And believe it or not, it's the water itself. Storm runoff. The water from rain that washes across or runs off driveways, roads, grass, and eventually into rivers and oceans. But how does this runoff, which fell mostly clean from the sky, become so dirty?
You can see there's a lot of debris in the gutter here and litter.
Environmental engineer Kate Bowditch is an expert in hydrology, or the study of water.
You know, the urban environment is actually a very polluted place. Initially, we thought pollution was just caused by factories and businesses and maybe broken sewer pipes, what are called point sources of pollution. Now we're discovering that the biggest sources of pollution are non-point sources. So that's pollution that comes from no particular place, it comes from everywhere. And that's really what stormwater runoff is. It's coming from the streets, the parking lots, the rooftops, the lawns. Pavement can't absorb the pollutants, so as soon as it rains, all that pollution is running off with the rain and collecting into the gutter. All that gets washed into the pipes and goes straight out into the Charles River.
Kate works and lives in Boston, Massachusetts, where the iconic Charles River flows through the middle of the city.
It was obviously once upon a time a clean, pristine river in a natural environment. The city was built, it gradually became more and more polluted. By the 1950s and 1960s, the Charles River was so polluted that it was really hazardous to human health. It was dangerous to fall in. The banks of the river were unattractive and smelly, and it was really gross.
The future was not looking bright for the Charles. Along with other environmental engineers, Kate used her knowledge of water, the environment, and the engineering design process to design clever ways to solve the water runoff problem. The engineering design process is a series of steps engineers use to solve problems. In the case of the Charles, engineers identified the problem. The Charles was dirty. They investigated the problem and discovered polluted stormwater runoff was a culprit. Then, they imagined innovative ways to solve the problem. They turned to the environment for inspiration. Soil and plants help clean runoff by acting as filters and separating out pollutants. As runoff flows through the ground, the grains and pieces of soil trap pollutants and separate them from the water. Plants can remove pollution by absorbing and filtering the water through their roots.
So anything you can do to capture the rainfall where it lands and soak it into the ground, especially through plants, that's really going to help reduce flooding and improve water quality.
After imagining, environmental engineers like Kate planned and created clever systems to help filter and clean the stormwater and placed them throughout the city, often right under your nose.
There's a bunch of things going on here. These are this walkway here is made of porous pavers. So if you look, yeah, you can actually see there's spaces in between these pavers where the rain can soak in, and yet, you know, this is a nice safe walkway. If somebody's in a wheelchair or using crutches or something, they can easily walk across this. So it's a good way to engineer a safe urban surface
That also
still
isn't just straight pavement, and so water can soak into it.
Many of these engineered solutions are simpler than you might expect.
This trench, which goes all the way around the parking lot here, it's filled with gravel. And the soils underneath here are very good, sandy, gravelly soils, so that water can flow right into the ground very easily. Now you can imagine before we did this, the pavement just went right to the edge and the runoff would just continue across the sidewalk and into the gutter.
So this was engineered, someone designed this.
Right.
And so this is a technology.
It's a technology, and this is a kind of environmental engineering, but it's super simple. I mean, we couldn't have a parking lot here for the school if this was all going to have to be an open field.
Yeah.
So you have to figure out how to combine the needs that you have in an urban setting with nature and figure out what's the right balance.
What are we doing in a ditch?
Well, it looks like a ditch, doesn't it? It's not actually a ditch.
It's not a ditch?
No, it's called a vegetated swale.
What's a swale?
A swale is like a ditch,
Uh-huh.
but it's different from a ditch. You can see that this swale is tilting slightly downhill in that direction, and it's designed to carry water slowly. So water is running off this parking lot through these openings in these bumpers, right down into the ditch that's actually a swale. The swale is carrying water slowly down in that direction, but it's also allowing the stormwater to filter through into the plants and soil underneath. So it's a fancy ditch.
Fancy ditch.
Yeah.
Many environmental engineers value this kind of simplicity. It's more affordable and requires less long-term maintenance. But this doesn't mean that all runoff systems are so simple. It's a matter of finding the right system for the job. And what's the dirtiest of the jobs out there? Streets.
Streets are one of the dirtiest places in the city. They get tons of automobile traffic, all kinds of stuff accumulates there. They have gutters, which collect a lot of debris and other things that can cause pollution. And so this site is actually not really designed to collect parking lot runoff directly. It's designed to collect runoff out of the street, a very polluted environment. So the way this system works is as water's running down this gutter, you can see it collects right here in the low point and flows into an opening in the gutter right here into this underground structure. So any litter, leaves, debris, big particulate material is going to be collected in here.
So that's one way that's getting the pollutants out, is they're getting kind of caught in those catch basins.
That's right. And then the overflow from this catch basin system comes out into this stormwater planter. And you can see, again, it looks pretty attractive. If you're just walking by, you might not notice that there was a stormwater engineered device here.
And it sort of flows down the planter, because you said it's sloped. Then it goes into a pipe and back into the Charles?
That's right. Yep.
Okay,
That's
so
exactly
it's like,
right.
so this whole thing is a big filter. You said it's a biofilter.
That's
And
right.
it, like all of the exhaust fumes and all of that pollution is absorbed by the plants?
That's right, and the soils.
And the
both.
soils.
Yep. Microbes and lots of living things in the soil, and they actually literally eat the pollution, a lot of the pollution.
But how successful are the systems that Kate and other engineers have designed? The next step of the engineering design process, test, will tell us.
The water quality results in terms of the monitoring that was done showed that the pollution removal was very, very high. So the water that they sampled before it was going back out to the Charles was virtually swimmable.
From public health hazard to virtually swimmable? Sounds like a success. But does that mean their work is done? Not quite.
In terms of cost, this was 10 times as expensive as the simple system that we were looking at.
Wow.
On the other hand, this is a very valuable pilot project. We learned so much.
So it sort of gave people the idea that, yes, this can work, and that's why we're seeing more around the city?
Yes, and in fact, if it didn't work or if things went wrong, we would learn those lessons as well. And the lessons that you learn are sometimes from failure as much as from
and then
success.
You can work to improve the next model.
That's right.
Improve is the next step in the engineering design process. Even when a technology works, there are generally always ways to make it better, like making it cheaper or easier to build. And finally, as Kate has shown us today, communicating the results are always an important part of an engineer's job. Sharing failures and successes can help other cities both nearby and throughout the world. For the Charles, the results of stormwater management are clear.
20 years ago, the Charles was filthy. Today, the Charles is clean. It's great. To be part of building those new innovative solutions and coming up with creative ways to rebuild the urban environment is just a fantastic opportunity. I've seen this river go from one of the dirtiest rivers in the country, and it's now been declared by the Environmental Protection Agency as the cleanest urban river in the United States.
Sounds like a job well done. But Kate insists the work is not over yet.
From a failing grade up to a B+, which is what we now get. And that's good, but it's not an A. Everybody wants an A. So we have a long way to go, and if we don't protect the gains we've made and continue to figure out how to solve these problems, we'll start slipping backwards, and things will get worse again. you.